Students solving February-March 2023 variant 52 question 1. Look, in this question, an electric pump is placed in a container of liquid. A model wind turbine is connected to the pump by a cable. Okay, I should actually, what does this wind turbine mean? Actually, it produces electrical energy, electricity, when blade is made to turbine by air blower in other words. Right, it's a generator. Okay, understood. The turbine is placed in a moving air. Okay, as the turbine blades turn, electricity is generated and the pump pushes liquid throughout the vertical pipe. Okay, the frequency of rotation of turbine blade is F and height of the liquid moves is H mass per unit time of the liquid leaving the top of the pipe. This is the relationship. Plan elaborate experiment to test the relationship. Look, this is a remarkable point. Okay, this is the remarkable point. Test the relationship between Q and V. You are asked to arrange an experimental setup where you can justify the relationship Q and F. Draw a diagram, okay, and how to determine C and D. These are the key points you have to mention in your experiment. You don't need to write answer in this order, right? Just write the experiment as usual, but in your experiment you should mention all this. Look, at best you can divide this whole question. Okay, you can answer dividing this in this way. Defining problems. That means in this part there are defining problems. In this part we'll get 2 marks actually, right? In this part you will be declaring independent variable, dependent variable, and any other quantities must be kept constant for flat test. Clear? Okay. Look, let us declare variables. Look, try to understand that experiment again. Airflow will make the blade to rotate. Electricity will be generated, that is transferred to the cable to the pump. Pump will pump this liquid, right, and the liquid will overflow through the pipe. You have to build up a relation, check the relation between Q and F. What is F? Frequency of rotation of this blade, and Q is mass of water pumped per second. Look, if they now look in every experiment, just follow few regular steps, right? That will make you safe. At first, find out the variables. Done. Then control variables. Then the way by which you can measure variables. Last one is how can you change the independent variable? You know, dependent variable will be changed automatically, right? Okay. In this case, these are the main variables Q and F. Now the question is which one can be changed by yourself? Definitely you cannot change directly the liquid flow through the pipe, right? You cannot change it, but you can change the speed of the moving air, right? If you place a fan here and if you change the speed of rotation of the fan blade, by using variable for supply, then your blue will be changed. So you can change F. Clear? You can change F. Okay. Then when F is changed, automatically P will be changed. Right? Now, how to measure F? Simple. You can color a single blade. Right? And then use this to determine the number of rotation of blade in 1 minute, then divided by 60. That will be the way, right? Best way to determine F. Now, how can you determine Q? Look, you cannot allow this liquid to flow to the beaker again directly, right? If you do this, then same liquid is returning to the same jar, same beaker. So it is not possible to measure the amount of mass of liquid, right? In that case, what to do? Connect a pipe. But very important thing is you cannot connect the outgoing pipe, outlet pipe, right, in this way, so that H is changed. You are not measuring this H, right? So connect a rubber pipe in that way so that H is not changed, right? And if this pipe on the liquid too fast, then it may fly, right? It may move. So to secure it, you should connect a what? You should connect a clamp with fitted to the stand, right? Then you can collect this liquid. Look, you have to make the figure is already there. You have to use this setup actually, this diagram, but you have to add some additional apparatus with this, right? Make it realistic, right? Collect liquid here, then measure the mass of it. Make it more realistic. Clear? Okay. Note one thing, when you are adding further devices, you must label them. If you don't label them, it is totally meaningless. Look, this might be an experimental setup. Where is it? This might be an experimental setup. Look, what additional apparatus added here? Fan. Fan is connected to variable voltage supply, or you can use a fixed voltage supply here with a variable resistor, your choice. In that case, you have to add a variable resistor in this pathway to change the current, right? Okay. If you use variable voltage supply, that means you are changing the variable regulating voltage, right, across the fan motor, regulating the voltage. Main purpose is you have to change speed of the fan so that the blade rotate with different frequencies. Clear? Balance, you can write it in what, not mandatory, okay, to draw, but okay, I added it to this diagram separately, right? You can add the balance just below the collecting beaker, okay, but in this case, um, your choice, you can, but you cannot lock the beaker actually. If you lock the beaker, you can use, right? It's a demand of the experiment. Even you can lock this, you can clamp this beaker, but in that case, you cannot place the balance directly, okay, below it. Clear? Okay. Now, look, these new apparatus, they are labeled properly. This is rubber pipe. This is rubber pipe. Stand, clamp. You can add another clamp as I told here. Ruler, fan, variable resistor, balance, and stop loss. These are right. Hope you understood. Okay. Now you don't need to describe this apparatus. Don't write anything on this. Install this. No, it has been added to the diagram. That's not. Directly go to the point. What you may write it this way: defining problems. Okay, defining problems. Defining problems. In this part, just declare variable. F is the independent variable, Q is the dependent variable. One mark. A should be kept constant during the experiment. That means you cannot change the pipe or height of the vertical pipe here. Okay. Then method of data collection, precautions, and other details. Right? Okay. At first, just focus on the measurement of variables. Fan is turned on, and when the speed of the fan becomes constant, number of rotation. Look, why is this important? Because if fan speed is changed, then what could be? Then amount of current produced would be changed. We don't want it, right? We want a stable output of the generator. So number of rotation of blades for 1 minute is counted. Stoppage is used. Right, you should mention the device. Then it is divided by 60 to get F. Yeah, as you know, F is the number of rotation per second. So main independent variable has been measured once, right? Now look for Q, measurement of Q. Q is the mass, but you cannot measure the mass directly. You have to collect it into the beaker, right? And one thing, Q is actually mass. Look, read it. What is Q? Q is the mass per unit time. Normally, per unit time means per second, but when we measure it, we we measure for a minute because it is very difficult to measure uh, the to collect the liquid for a second, right? You can use mass per minute also, but I think better convert it into SI unit. So mass per unit per second actually. So what is done here? Look, divide this number to get F. F is found out. Mass of empty beaker is measured. Then water is collected in the beaker for a minute. Mass of beaker with water is measured. Okay, I wrote water here. Mm, they mentioned liquid, so change it by liquid. Liquid. Mass of liquid and mass of okay, mass of liquid is equals to mass of beaker with liquid minus mass of empty beaker. Mass of empty beaker. Okay, done. Then Q is equals to mass of liquid by 60. Unit will be kg per second. Measurement is repeated for few F. For same F, for few, this is actually precaution. Okay, this is not a core part of the experiment. Actually, for precaution, for same FQ should be same, but because of experimental error, right? Q might be fluctuating. That's why to reduce the random error, you should repeat for same F few more part. And when you repeat something in this way as a precaution, then you should mention average. What thing need to be averaged? Okay. Now, this variation is the part of the experiment because you have to plot a graph. You need data, at least 6 set of data. So to vary F, speed of rotation of fan is increased by increasing the voltage or current. You can mention chains here. Exponent is repeated for different values of f and corresponding q is determined. Hope you understood, right? H is measured by using plumb method. Why? Look, for every constant factors, there should be a single measurement. There is a demand also how to determine C and D. For this part also value of H is needed. If it is not needed, in that case also you should record a single measurement. So H is measured by using a clamp meter rule. Clamp meter rule is there, right? Okay. Now you can add additional details here or at the end of analysis part, right? My suggestion is already a few points of additional details are there inside, right? How? Look at this. Uh, how mass of liquid is measured. There might be extra point. Then when you F when measured F is measured, then number of rotation, okay, for 1 minute has been recorded. So that's a D point, right? So now you can add any additional details here, right? This is my suggestion. So further details are it could be like this. When you are counting the number of rotation of blade, you can color one blade so that you can easily count how many times does this blade rotate. So you can add it here. Uh, yeah. So now come to the remaining points. My advice is any other additional points added here. You can give bullet or you can write line by line. As per example, look, as a safety precaution, did they ask for safety? Taken control analysis data, safety precautions to be taken. Okay, safety safe distance from blades maintained should be maintained, right? Otherwise you would be hurt or air blow will be there. So you can add another precautions. Safety goggles to protect eyes from dust, or air blow. Okay, so this could be safety precautions. Then, right, other precautions or other details. For example, um, one blade can be marked with colors to assist number when counting number of rotation of turbine blades. Okay. Then what other precautions should be there? Look, position of fan, position of fan and turbine, not only position and also orientation. Fan and turbine blade. Turbine blades cannot be changed, right? And also you can write um, student should wait for steady airflow and also there should be no other airflow. You can add it as a separate point. Other airflow should be avoided. Should be avoided. I mean, as per example, windows, should be kept closed during the experiment. Example, as for example, okay, kept closed during the experiment. During the experiment. I think enough D points already collected. Now come to the next word. Look, there are many additional points. You need only six. So some of them are already there in the main experimental part. Now add, right? Okay, if you can, if you think that some other points should be added, you can add it here. Now come to the last part, method of analysis. Method of analysis. Look, in this part, always method of analysis. Look, in this part, always you have to plot a graph, but where you have to change the variables of y-axis. You have to choose right quantities in y-axis and also x-axis the graph so that you get a straight line. Look at this. This equation is what was the relation? Relation was proposed equation is QGAC plus U QGH is equals to C plus TFQ, right? Now, look, you have to plot a graph. Your main variable is F and Q, right? Your main variable is F and Q. Make Q subject first, right? Y variable must be single. The quantity that okay you are sending to the y-axis of the graph must be single, right? Make it subject first. So it will be Q is equals to C by GH. This is H. C by GH plus D by CHFQ. The y variable must be, okay, you have to make it subject quantities which is going to y-axis, right? Now it has y equals to C plus mx nature if q against fq graph is plotted. Okay, what will be the nature of the graph? So what should you write here? Give this, okay, give all these here, then write a graph of q against f cube. This means that q will go to the y-axis, f is in the axis. It's plotted. You don't need to plot the graph. Just write graph should be a straight line. Graph should be a straight line with dotted line will not pass through origin. Okay, now come to the point. Gradient of the graph will be gradient of the graph will be T by GH. Look, H has been measured already, right? So there was a question how to determine D. So write D is equals to GH into gradient. D is equals to GH into gradient. Okay. Look, this is written Y because look at this. How can you determine D? Still, you have to determine C. Then what to do? Look, it is in y-intercept, right? C by G. So write y-intercept. Y-intercept is equals to C by GH. C by GH. So C is equals to GH into y-intercept. So this is a method of analysis. Okay. I added all additional details, procedure and precaution in other parts. If you want, you can add additional details after method of analysis, right? And that's the end of this question 1. Okay, we shall discuss on question 2 later on. Thank you all.